Fluid Power Systems, Part 2 of 3. Basic scientific concepts of fluid power. Mechanics is the study of forces and their effects on the bodies on which they act. Fluid mechanics is concerned with the study of properties of gases and liquids that are at rest, hydrostatic, or in motion, hydrodynamic. Fundamentals of hydrostatics. Hydrostatic systems transmit energy through fluid pressure and convert it to an output force. Fundamentals of hydrostatics, Pascal's law. Pressure of a confined fluid is equal throughout a closed system and acts perpendicular to the containing surface. Here we have a formula, Fi over Ai equals Fo over Ao. Fi is the input force, Fo is the output force, Ai is the area of the input piston, and Ao is the area of the output piston. Hydraulic amplification of force. The ratio between the output and input forces of the pistons in a hydrostatic system is inversely proportional to the distances that their pistons will travel. So here we have our output force over our input force is equal to the distance moved by the input force divided by the distance traveled by the output force. Fundamentals of hydrodynamics. Hydrodynamics is the study of fluids that are in a state of motion. Basic concepts of hydrodynamics include viscosity, the difference between a fluid's flow rate and flow velocity, and the effect that a change in a fluid conduit's cross-sectional area has on the pressure and velocity of the fluid that flows through it. Viscosity. Viscosity is a measure of a fluid's resistance to flow. Fluids such as petroleum-based hydraulic oils are characterized as thick and viscous. Hydraulic oil serves two purposes within a fluid power system. It must transfer energy through the flow of pressurized fluid, and it must lubricate the moving parts within the system. Hydraulic oil should have enough viscosity to serve as a proper lubricant and to prevent leaking past seals. On the other hand, the viscosity must be low enough to ensure proper flow through the transmission lines. Liquid flow rate versus flow velocity. Hydraulic fluid should flow through a pipe in a smooth, steady stream. This is referred to as laminar flow. If fluid is forced through a transmission line too quickly, it will experience turbulent flow. Flow rate, Q, is the volume, V, of fluid that moves past a given point in a system per unit time, T. Flow rates in hydraulic systems are measured in meters cubed per second. So here's the formula. Q, the flow rate, is equal to the volume in meters cubed per second. The speed of a fluid moving through a system is referred to as the flow velocity, the Greek letter nu. Flow velocity is a ratio between the distance, x, that a drop of fluid travels and the amount of time, t, that it takes to travel that distance. Flow velocity is measured in meters per second, and so here we have nu, our speed of a fluid, our flow velocity, equals the distance, x, in meters, divided by time, t, in seconds. Reducing the diameter of a fluid transmission line will cause an increase in flow velocity. If a fluid's passageway decreases in cross-sectional area, A, then the fluid's flow velocity, nu, must increase in order to maintain a constant flow rate. So nu equals the flow rate, Q, divided by the cross-sectional area, A. Bernoulli's principle. As a fluid moves from the source of pressure, it will usually experience changes in the cross-sectional area of its pathway. These changes in cross-sectional area affect the velocity and pressure of the moving fluid because of a fundamental law of hydrodynamics. Bernoulli's principle states that the velocity of a fluid increases as the pressure exerted by that fluid decreases. A Venturi tube is a constriction that is placed in a pipe that causes a drop in pressure as fluid flows through it. The decrease in fluid pressure is accompanied by an increase in fluid velocity. The reduction in fluid pressure that occurs as a fluid flows through the constricted section of pipe is referred to as the Venturi effect. A vacuum generator is a pneumatic device that incorporates a Venturi tube to generate suction by accelerating the flow of compressed air. Vacuum generators are frequently used in assembly, packaging, and manufacturing operations to lift and clamp objects. This ends Part 2.